So today we're going to be talking about Bernoulli's principle that talks about conservation of energy. Along a streamline, if we have point A and point B, the energy on point A will be equal to the energy at point B. So if velocity increases here, the pressure should decrease to maintain equal energy on both points. Right now, Ilona is going to show us an experiment where she is going to blow air on the top of the paper and you are going to observe what happens next.
Let's see.
And Reddy is going to explain.
So this demonstration is very similar to the lift in airplanes. So Bernoulli's principle demonstrates this lift. So when Ilona blew on the top of the paper, she exerted a force with high velocity. And as Noor explained previously, high velocity leads to a decrease in pressure. So we create an area of low pressure on top and an area of high pressure below, which is the atmosphere, which is the same, and it becomes higher than the pressure on top. And that is why the high pressure will flow to the low pressure and lead to this lift.
Now we're going to show you many other experiments that will demonstrate Bernoulli's principle. We're going to explain Bernoulli's principle. For this experiment, we're going to need a hairdryer and a ping pong ball.
How does that happen?
Let's see why. So, when we exert a high velocity, the pressure below the ball becomes low. However, the pressure above the ball becomes higher. So even though when we tilt it sideways, the ball will remain in place since high pressure flows to the place with a lower pressure. We're going to use two papers, each paper attached to a string and a straw. So we're going to blow through between the two papers. بس ثانية, just a second. So the papers touch each other.
Is that Bernoulli's experiment?
Yes, it is.
Yes, it is indeed. So what happens is, when we blow between the two papers, we're applying a high velocity. And when we apply high velocity, according to Bernoulli's principle, the pressure decreases in between the papers. So when the pressure decreases, the pressure of the atmosphere outside becomes higher, and the high pressure allows the suction of the two papers together. So now we're going to try a third demonstration for Bernoulli's principle. We have a hairdryer, a straw, and a cup filled with water. So as you can see, we see that the water was absorbed by the straw.
Why is that? This is Bernoulli's principle again. So when we apply a force with a high velocity, the air pressure above will decrease. So the air pressure here will become higher than the air pressure above. That will lead to the suction of water inside the straw.
We are going to demonstrate another way on how Bernoulli's principle works. We're going to put the ball under the high velocity.
How does it work?
Interesting question, Ilona. So once again, we apply Bernoulli's principle. When we open the tap water and we apply velocity on the top of the ball, the pressure decreases. However, on the other sides of the ball, the pressure is still the same, and it's higher than the pressure on the top. And that is why the high pressure flows to the low pressure, and this is why the ball is attracted to the water. And as well, we can notice when we move the water, the ball is still attracted to the flow of water, and this is because of Bernoulli's principle.